So our topic today is going back to EVAP. It's been a while since we've talked about EVAP systems, so we're going to kind of do a little refresher course and talk about some new material as well. So EVAP systems, operation, and testing. So we're going to start off with, well, what components really comprise the EVAP system? So first off, we have the Purge solenoid we're going to talk about. That is on the, I'd say the front end, the engine side of the system. Then we have the vent valve, which is on the opposite end. Then we have the canister, which is kind of in between. We have the fuel tank pressure sensor, which of course is on top of the fuel tank. And then there could be other pumps and associated diagnostic modules for that. There's a lot of, nowadays, there's a lot of those kind of leak detection pumps and things of that nature on the system. So it doesn't actually do it while it's driving. It more does it after the fact, after a cool down period. So we'll talk about a few different ones of those and a few different gotchas that you might run into on that. And then, of course, we'll look at some live stuff on the tool and see what we can see there. So first off is the Purge solenoid. And as I said, that is up closest to the engine, generally speaking. And that is the solenoid that opens up and allows the EVAP vapors into the engine. Now, many times, not always, but many times is a pulse width modulated solenoid. So what that means is they increase the amount of on time or off time with the solenoid to open and close it at a certain percentage, maybe 10% up to 100% open and close, depending on how fast they need the vapors to come out. It's also used for leak testing because that's basically like the front door of the system. So we have to block that off once we draw a vacuum down on the system. We'll talk a little bit more about that in a minute, but these can fail fairly commonly. I mean, it's a pretty common repair on a vehicle. Now, this next slide, this was a little bit different. So I found this on Honda. So last week, I had asked during the 100th episode if you had any suggestions for what else we wanted to talk about here, any suggestions for courses or things like that. When we had a contest entry. And one person said, well, I heard, so you're doing EVAP next week. Can you talk about Honda? Because Honda has 2 vent valves, they had said. So I looked into it, and it's actually not vent valves, it's purge valves. And it's not necessarily it's a purge valve and a purge diverter valve, basically. So we have the purge valve here on the left, which is going to be your main purge valve. That kind of comes off the tank and then it goes into the engine. But we have this two-way diverter valve here too. So you see it kind of goes, that's the main purge solenoid. It's going to have my vapors come out. It's actually got two lines there. And then it goes into this valve here, which can kind of divert it either way because this is a turbocharged vehicle. A lot of the 1.5 liter Honda engine uses this. And so it'll either plug it in before or after the turbocharger. So if we look at this little diagram that Honda printed out, so it comes out of the tank into the canister, into the purge valve, and then there's a valve A, which sends it into merge point 2, which is after the turbocharger, and then non-return valve B, which sends it to a merge point before the turbocharger. So really, it depends on whether it's in boost or not as to which direction those purge vapors go, and sometimes it'll go in both, depending on what the pressure is like inside the intake manifold. So that was it. I didn't know that. That was interesting. So it makes sense if you think about it. Under boost pressure after the turbocharger, it might just blow it right back into the canister if you don't provide protections for that. So having that avoids that. So if it's under boost, it'll actually go on the sucking side of the turbo, basically on the intake side of the turbo, and burn it that way. So I thought that was kind of a good tip, good suggestion from one of our viewers there. So thank you for that. Next one's the vent solenoid. So that's basically the back end. So if you think of the purge valve as like a front door to the engine, then the vent valve is your back door coming out the back. So what that does is it's an electronic solenoid. Usually it's on off, just open or closed. It allows fresh air into the canister. It also allows fresh air to get out of the canister if I'm trying to fill it. Can also be used is also used for leak testing because you have to close the back side in order to test for leaks, and it may actually be part and parcel of the canister. A lot of times nowadays, it's part of the canister, it's part of the leak detection pump, or maybe that whole thing's in assembly. So there are issues with these. There can be issues with these. I know at Subaru we had a lot of problems with the vent system, not necessarily the valve itself. The vent valve to a point, I guess, because it was under the car and I always got a bunch of sand and salt and road crud on it, so it would always get corroded. So we'd have to fix the harnesses. But in this case, Mazda got so bad, and this is a common problem. I'm pretty sure it's on multiple brands. Mazda's the only one I know that recalled vehicles for it, but the symptom would be the customer would come in and they would say, "Hey, I can't fill up my gas tank. I know it's empty, or I know it's a quarter full, or whatever it happens to be. I'm trying to put gas in it, and it shuts off immediately. You know, it goes like pump up, click, pump up, click. Won't let me fill the tank." Well, the problem was on those that there's an obstruction in the vent line somewhere, either close to the valve or in the, maybe the little hose that comes off the valve and goes up into the atmosphere. So what it is on certain Mazda 6 vehicles, and like I said, other brands of vehicles that have the same problem, a certain type of spider, this golden orb weaver spider right here, may weave a web in the evaporative canister vent line, and this may cause a restriction in the line. If this occurs, the fuel tank pressure may become excessively negative when the emission control system works to purge vapors from the canister. In other words, it can't get any air in to displace the vapors, so it runs into a vacuum and it could collapse the tank. As the canister is purged repeatedly during normal operation, the stress on the fuel tank may eventually result in a crack, potentially leading to fuel leakage and an increased risk of fire, all due to this little guy. So when you see it, it's going to look like maybe like a little cotton ball stuck in there. Over there is what it looks like after you cleaned it out. Now you can stick a little screwdriver, blow a little air in it or something like that. Make sure you point it away from your face when you do, because the spider could still be in there. But just open the vent and then it'll happen. Now, I've also heard not spider related on like Chevy trucks, because the vent valve, where the vent valve is like above the spare tire. And a lot, as you can imagine, a lot of mud and grime and dirt and all that sort of things and rocks get up in there in the vent, and that can get clogged that way. So that would cause a similar problem, right? Excessive vacuum. And then it would also, could cause excessive vacuum. I've heard, some of the ones, the plastic tanks, the tanks actually collapse. So something to look out for. If the customer says, "Hey, I can't put gas in my car," that's probably the first place you should look is the vent valve, because vent valve lets the air out of the tank when you're filling it, right? And then the pump knows that the tank is full when no more air is going out, and actually kind of goes back into the pump. It's actually a really cool YouTube video. I forget where it is, but the guy actually cut one in half and he shows how it looks and how it works. It's kind of neat. If you don't really know, you just kind of think you know how it works, but you don't really quite understand. It's a good watch. All right. Next one's a canister. So we talked about the purge valve. We talked about the vent valve. Now let's talk about the canister, where all the magic happens. So that is what collects the EVAP vapors. So the gasoline vapors out of the tank goes in here, contains activated charcoal to kind of store it. And it may also contain electrical components as well. Like I said, the vent valve on many now, and actually the leak detection pumps and all these other things, are part and parcel and pieces of that canister. So sometimes you can't even get the vent valve separate. You have to buy the whole canister assembly. And then lastly, the last thing we're going to talk here is going to be about the fuel tank pressure sensor. So this is going to measure the fuel tank pressure, as it says on the tin. It's going to output a voltage depending on the pressure. So, the voltage will go up or down depending on what the pressure is. Usually a 3-wire sensor. It's going to have a voltage power supply, so usually 5 volts. It's going to have a signal wire that goes back to the computer, and of course a ground to ground it all. And here's an example here. So this is on a 2016 Tahoe. So we have the fuel tank pressure sensor there. And it's going to be key on, engine off. Voltage should be about 1.3 to 1.7 volts with no pressure or vacuum. Remove the gas cap to make sure there's no pressure or vacuum in the tank. Just pop it off and let it equalize. Replace the fuel cap. As vacuum builds in the fuel tank, voltage will increase. With pressure, voltage will decrease. So if I'm adding pressure, it's going to go one way. And if I'm relieving pressure, it's going to go the other way. Easy. And then we also have, like I said, automated leak detection devices now. So instead of the fuel tank pressure measuring and checking the vacuum decay on the system, they do this automatically using a pump after the fact. So in this case, we have a whole bunch of stuff here. We got the little pump right there. It's got a vent valve in it already. And so a little bit of the canister. This is kind of a whole piece meal together of a large amount of the EVAP system. So this would be on a like a Subaru, right? So 2011 Forester in this case. Leak detection pump and sensor are used as pair, not only to detect evaporative leaks, but also to detect the size of the leak, because it can quantify it when it pulls a vacuum. The leak pump will draw vacuum on the evaporative system. The pressure sensor will then monitor the system in the tank and look for any leaks. A drop in voltage would indicate a leak in the evap system. Leak detection pump is part of the vacuum pump module assembly, combining a vacuum pump with a drive motor, canister vent valve, and the pressure sensors all together. ECM is going to command the vacuum pump to apply a vacuum to the evap system during a self-test. It's either the canister vent valve or pressure sensor. Go to evap system section of the main menu. None of the internal components can be serviced separately. If any fail, the vacuum pump module must be replaced. The whole shebang. It says, due to internal circuitry of a leak detection pump assembly, motor resistance cannot be checked, so you can't really check the motor. If the motor fails, it fails. The DTC indicates concern with leak detection pump and powers and grounds and wiring. The ECM are okay. You'll need to replace the pump module assembly. There's your pinout right there. We got vent control, 12 volts to the pump, leak detection pump ground, 12 volts to canister, 5-volt reference, and so on. It also shares this exact system with Toyota Avalon, Toyota Camrys, a bunch of Toyotas. Toyotas and Subarus share the same basic system. And then here's how it kind of works. So there's a key-off monitor. It's going to check for evap system leaks and canister pump module malfunctions. It starts 5 hours after the engine switch is turned off. At least 5 hours are required for the fuel to cool down to stabilize the evap pressure, thus making the monitor more accurate. So it waits 5 hours. You may have heard this before. You walk out in a parking lot, parking space, your driveway, whatever, after being parked for a while, and you hear like a little buzzing noise underneath the car. That's the pump running the test. So basically, it's just running the evap monitor 5 hours after. If after 5 hours it's not cool enough, then it'll check two more hours. If it's still not cool enough, cooler than 95 degrees, 7 hours, it'll check 2.5 hours later. So it could take up to 9.5 hours to test this system. So there are functional tests in the scan tool on Toyotas and Subarus that'll force this test. There's also automated tests on Toyotas that'll walk you through it too, and you can watch the vapor pressures go up and down as well. And then it just gives you a little bit more. It's going to tell you how to run the monitors on that. Another version here is the eSIM on Chryslers. So that's the EVAP system integrity module. It's a little vacuum operated module that checks for leaks as well. It's going to kind of tell you how it works. It's very similar to NVLD, which would be the natural vacuum leak detection pump, which are natural vacuum leak detection, which they used earlier designs. The design of the eSIM has been simplified, so it does not require a solenoid. Before we did. The eSIM mounts directly to the canister, eliminating need for a mounting bracket. It's critical that the eSIM is mounted vertically on vehicles where the canister is mounted at an angle. eSIM requires an adapter to maintain a vertical position. When the eSIM is installed vertically, the electrical connector is in the 3 o'clock position. The assembly consists of a housing, a small weight, and a large weight that serve as check valves, a diaphragm, a switch, and a cover. There's one large weight and one small weight check valve in the eSIM assembly. Seal is attached at the end of each weighted check valve. The large weight check valve seals for pressure. Small weight check valve seals for vacuum. Weighted check valves are contained within the eSIM housing itself. So that kind of tells you how it works. And depending on this placement, either 1 or 2 EVAP canisters may be used. Also, depending on vehicle model and fuel tank size, canisters may be mounted either vertically or horizontally. So you can see there, it's just a 2-pin power and ground. BMW uses a similar system, and actually we'll see on the newer ones, they actually use an that thing. They use a NVLD, natural vacuum leak detection. I had to look up the acronym. So on the newer ones they do, but on some of the older systems they'll use this. This is on like a 2010 335. There is a test for that, EVAP tank leakage diagnosis. And DMTL stands for Diagnostic Module Tank Leakage. To give you a little theory operation, the tank leak test itself, system actuators, and diagnosis and symptom tips. So I'm not going to read through this whole thing, but you could go in and look it up yourself if you wanted to. But in its inactive state, filtered fresh air enters the EVAP system through the sprung open valve of the pump. The DME activates the pump for leak testing. It first activates only the pump motor and pumps air through a restrictor orifice, causes the electric motor to draw a specific amperage value. So the ECM checks how much current is flowing through that on a regulated size orifice, so it knows how big a leak would have to be at a 1 millimeter or 0.5 millimeter size. So depending on how much current draw is on this motor, it measures to see what kind of leaks it has. Software error in the DME calibration may cause the mill to illuminate as well for EVAP system failures in vehicles equipped with manual transmissions that are driven under the following conditions. So that could cause an issue as well. And let's talk about how it operates. So now we know the components, we know the overview, we kind of know how they work. We're going to walk through how basically the system works, how it works when it's working, and how it works when it's testing as well. So we got this nice little animation here. Remember how I said the purge valve is the front door and the vent valve is the back door? So the back door has to stay open under normal operation due to that obstruction like I talked about earlier. So if the vent valve is obstructed in any way or closed, then you can't get gasoline into the tank. Notice how we have an empty tank of fuel here. So the back door needs to be open, front door needs to be closed under normal operation, and then I add fuel. So we add fuel. Now I got a full tank. All the vapors are going out. The vapors are then going to be collected in the canister, which is going to displace the fresh air that's in there, and it's going to go out the back. Once my fuel tank is full, we're going to leave the back door open because we need fresh air to come in, but then we're going to open the purge valve. Once we're up to temperature, we're going to send a signal, open the purge valve. It's going to cause a vacuum in the system. It's going to suck in outside air, clean air, which displaces the vapors, and it gets back into the engine to be reburned. Great. Now while it's running, it's going to leave this open, and then it's going to close the vent valve. Once it closes the vent valve, electronically, of course, it's going to draw a vacuum on the system. So then we're going to watch the fuel tank pressure sensor. It's going to recognize a vacuum. Once it is in vacuum, it's going to close the purge solenoid as well. And now the whole system should be under a vacuum, and that's how it checks for leaks. It is going to start a timer. Once that timer goes to the end, it is going to measure how much did that vacuum drop. Did it drop? Did the voltage change on my pressure sensor? If it doesn't drop, then we know we don't have a leak. However, if we draw a vacuum and it does drop, depending on how fast it drops, the computer can then quantify the size of the leak. That's what I was trying to say. So that's how we get the codes that give us different size leaks. So, for example, 440 is just a general EVAP problem. 442 is a small leak. 456 is a very small leak. 455 is a gross leak. 457 is counted as a gas cap, right? So those are all leak codes. However, you do also need to be aware, and you need to keep this in mind anytime you get an EVAP code. Don't just see the word EVAP and assume it's a leak. Don't fall down that rabbit hole, because there are other codes that can be electrical related. So 443 is a purge control solenoid electrical problem. 446 is a vent control. 452 is a pressure solenoid. 458 is a purge solenoid, et cetera, et cetera. There can be, I've seen different codes that are like flow rates and stuff like that. So you need to make sure you're reading the definition of the code so you don't go down the wrong path. Oh, if it's an electrical code, more than likely it's probably not a leak. Or if it's a leak code, more than likely that could be an electrical problem, I suppose, too. Like if my vent valve was stuck open or something like that, that'd give me a gross leak. But more often than not, the computer's pretty good at kind of sussing out roughly what the problem is, whether it's a leak or whether it's an electrical problem. So that's what you need to be aware of. Just make sure that you're reading the definition of the code before you just go down and just start checking for leaks. First thing, leak testing. Now, I will say the easiest way to test for leaks is to use a smoke machine. It's Halloween right now. There's a lot of smoke machines out. That's probably not the best kind of smoke machine to use for a car, maybe in a pinch, but the fluid's not good for it. We do have a couple different versions. There's a lot of other different versions out there of leak detection systems. And boy, I'll tell you, when I worked at the dealership, we didn't have one, and it would have made my life a whole lot easier if I had at least something to generate smoke. I didn't even care if it had a gauge on it. If I had smoke, I could figure out where it's coming out. Because there's all these random rust holes and rubber lines and all sorts of things that would go bad on those cars. So having one of these would have been a wonderful thing. But this is our smart smoke. It's the only digital one on the market, so it actually allows you to quantify the size of the leak. We also have one with the gauge, right? We got a couple of different ones of those that are out there as well. But the important thing is being able to test it and quantify the size of the leak, because, for example, 455 is a gross leak, a large leak. 442 is a small leak, 40 thousandths or greater. And then 456 is a very small leak, up to 20 thousandths. Now, the 40 thousandths was spec to 99 and older vehicles. On 20 thousandths was spec on 2000 and newer, and now we're down to tenths, 0.10. on a lot of Chryslers and other vehicles. And there's actually, like, for example, you see any vehicle running around. I know a lot of Subarus were like that, but it says PZEV on the back, partial zero emissions vehicle. That's going to be the EVAP portion of the emissions would be the zero part. So the partial zero is going to be the EVAP portion. In this case, we had a leaking vent valve, so that could be an electrical problem with the vent valve, or it could just be a bad vent valve that's not electrically broken, but it would cause a leak code, right? So just pump smoke in. Where does smoke come out? Makes the unseen seeable. This is another one where they kind of cross-threaded the sending unit, and they didn't really realize they did, and it came up with a small leak code, so it ended up being a cross-threaded sending unit, and you can see where the smoke's coming out on top of the tank there. And then lastly, there's a canister right there, and you can see that there's a crack in the line. It's just dry rot hose, and you can see the smoke just pouring out of there. So yeah, that's a fairly obvious one. But if you didn't have the smoke coming out, it would have been taking you a while to figure that out, right? So I would say that is the most indispensable tool, no matter whose it is. I don't even care. Just having a smoke machine at your disposal, having an EVAP tester at your disposal, makes life a whole lot easier when it comes to testing for leaks, right? Because then at least you can see roughly where it's coming from and then go from there. When it comes to electrical testing, that's a little bit different, of course. Of course, I need to know where things are located. I need to know how they work. Is it an on-off solenoid? Is it a pulse width modulated solenoid? Most of these things are going to have 2, maybe 3 wires on a fuel tank pressure sensor. When we start getting into like the leak detection systems and leak detection pumps and things like that, yeah, then you might have 8 or 10 different pins on there. But mainly, like in this case, on this Camry, it's a 2022 Camry. It's a 2-year-old car. That's 12 volts and ground on the solenoid, right? So that's on the Purge solenoid. So it's 12-volt power and ground. Simple enough, right? Might need a wiring diagram and a tool to test it. So let's do a little live walkthrough on the tool. Got a couple different ones I want to look up. Actually, I'll do the Camry first in here. So on that Camry, if we go into like engine, right? And we do functional tests. Should be a special function in here for that. Maybe it's not under special functions. Oh, I'm not gonna be able to find it on this one, I don't think. Well, I can activate the different valves though. Vent valves, fuel vapor containment. Oh, fuel vapor containment valve. That's what I wanted to talk about on this. Because it's got another valve in there by the tank that kind of separates the tank from the rest of the EVAP system on occasions where that's needed. So there's a fuel vapor containment valve, vent valve, purge valve, vacuum pump for that. So you can manually do that. There is also an automated test for it. I just can't seem to find it on this particular car right this second. I think it would be under routine tests if I was hooked up to a real live car, but since I'm not, it's not going to list it for me. But I wanted to show you this in Shopkey. There we go. And I will tell you, this is a 2-year-old car. 85,000 repair record. Number 4 code, EVAP. Number 7 code, EVAP. Most vehicles that you look up, you're probably going to find at least one EVAP code. So this is a 441 EVAP system incorrect purge flow. And then there's one here, gross leak, right? So we'll look up the purge flow. And we'll just pull up the general diagnosis. So if we go into operations, it's going to kind of tell us how it works. There's a lot of different thresholds and stuff. I'm just going to go down to the general EVAP system here, because that was for the code. But here's like a little diagram, right? So we got the leak detection module, a bunch of other solenoids there. There's a purge solenoid there. All right, and then so there's a canister pump module, canister and pump module. And there's a couple different ones depending on what it is. Purge flow, pump module, reference orifice. soak timer, right? So that's on a different model. There is a separate valve on top of that tank, which I'm trying to look up. Purge flow monitor. It's 19, 2020. There we go. Kind of tells you how it works and how it pumps and things like that. I'm not seeing that fuel tank module there. Okay, never mind. So I'll actually go into the vent valve. Should be it. Bring me back to where I was. Oh. Okay. Guess we're not seeing, actually, should be in here. That should be in the 441. Under testing. Tells you all sorts of cool things about monitor strategies and purge flows, things of that nature. All right. There is a little thing in the back by the tank that closes off the systems, which I wanted to show you. For some reason, it's not getting me there. But anyways, so that's the Camry. And let's look up this Ford Escape, which is going to be a little different. So this has a cold soak time bypass. So that's going to have another time where it needs to wait for it to leak down. So there's going to be a cold soak time bypass there. There's a small leak test and a gross leak test, so you can do automated as well. So that's on 4. There's a couple different things you can do in there. Let's go into shop key quick. Let's see. Oh, look. EVAP flow during a non-purge condition. That's number 3 on there out of 127,000 repairs. So go in there. Going to give us kind of a rundown there as well. EVAP blocking valve. All right, so that's like a similar type item as what I was talking about before. Canister. Canister purge valve. Vent filter. So there's your vent valve with the canister as well. Part of the canister. So really what I'd want to do is I'd want to look up, say I wanted to do a canister purge, and I wanted to look up a wiring diagram, for example. Go in there. And then there's my purge valve there. Right? It actually shares power with a couple things as well. So you're going to have power and ground, right? It's fairly straightforward on most of these. Purge valves, vent valves, a lot of them are just on off. So there's not a, you kind of need to look in like the, like in guided component test is a good place to go. And go into, say, the EVAP system here. And there's the vapor blocking valve, the fuel tank pressure sensor, the purge solenoid, and the vent solenoid. So the vapor blocking valve. It's normally open valve. PCM closes the blocking valve to isolate the fuel tank from the rest of the EVAP system. The EVAP vapor blocking valve will automatically open or relieve excess pressure or vacuum in the fuel tank. So that's actually where I found it earlier, but the Toyota has one too. So you can see that in there. And then there's a voltage test. You can see, whatever you need to see. 12 volts should be present. Or on the purge solenoid, that's got a location image in there. So there's where the purge solenoid is right there, kind of on top of the gooseneck there. Component information, purge valve control, and fuse number 35 or circuit breakers. That's nice. Signature test, going to show you what it looks like. It's pulse width modulated in that case. All right, so let me go back to that Camry real quick. That's actually what I wanted to show you. And I got mixed up. So there. The detection pump, right? So that's got the pump. It gives you all the reference pins on the pump. Due to internal circuitry leak, pump assembly motor resistance cannot be checked. DTC indicates concern. You have to replace it. It's going to give you system operation. Kind of tells you how the whole thing works. Also, it's like the Purge solenoid. That's got a location image as well. That's right on top. Right there. That's nice. Signature test. That is a open close kind of solenoid, so you can see how it goes. Opens and closes like a solenoid. Even a tech tip in here. If no short to ground or open circuit exists, remove the EVAP vents, VSV hoses with blow-through ports. VSV is normally closed. Air should not pass through. When checked on a running engine, vacuum shouldn't be present at a port, nor connected to manifold vacuum source with VSV connector unplugged. This is the Purge solenoid, and using small jumper leads, apply battery voltage to the EVAP vent solenoid valves. Battery power to the venting solenoid valves should pass through the ports of OK connect hosing connector. There we go. So a few little tips there. And then lastly, we have this BMW 2020 440. Engine. Functional tests. And there should be something in here somewhere. Oh, wait, it's not in there. So there's a tank ventilation valve. You can open the solenoid. This actually uses natural vacuum leak detection. So it doesn't have like a pump that it'll test. If I go in here, just reading it earlier. Guess that's got the wrong engine in there because I had a lot more returns earlier. So I got one. All right, whatever. All right, so that I have wiring diagrams in there. Bunch of different things. I was in the got a component test where I found it. NVLD unit, right? So it uses natural vacuum leak detection. Unlike the conventional leak detection system, the NVLD system operates on natural vacuum. Natural vacuum occurs in the sealed fuel system after it starts to cool and the pressure drops. After a predetermined amount of time, the temperature is dropped enough, vacuum will build up and close a vacuum switch. This vacuum switch is monitored by the NVLD diagnostic module. If the pressure in the fuel system remains high and the temperatures drop below a predetermined value, the NVLD diagnostic module will report back to the ECM that a leak is present, or if the vacuum switch is closes and then opens again after a predetermined amount of time, a fault will be set for a leak. Test is a long test, approximately 12 hours, and the vehicle must be in a rest state. So really it's an overnight, and there's no short test possible with this type of system. If the fuel cap is off or loose, trouble code will set. Check for this first before looking for leaks in the system. And then it gives you the diagram for the module and stuff like that. Engine may use either the NVLD module or diagnostic module tank leakage, which we talked about a little bit earlier, that DMTL, but not both. So it's one or the other. So I guess you just kind of have to figure out which one is on the vehicle before you go and test it, because I would imagine there's going to be different ways to test it. And then as far as the Purge solenoid, right, it's going to go into the charcoal filter. Right, so it's just going to be two wires, open, close. Simple enough system. So really, I think the biggest challenge when it comes to EVAP is going to be first discerning the code. That's where it all starts, right? Do I have a leak or do I have an electrical problem? Electrically, they're fairly simple. If you have the right tooling to test them, most of them are just 12 volts on or off, or it's pulse width modulated signals. So you can do that with, a scope or whatever. And then if it's a leak, having a leak detection device like a smoke machine, EVAP detection system, whatever you want to call it, that's invaluable as well, because that'll save you a ton of time when it comes to that type of stuff. If you don't have one of those, it's and you're taking a long time doing EVAP testing, that's probably why. So yeah, that's EVAP testing. So let's talk about what we're going to talk about next week. Next week is going back to our OEM specific training with Hyundai and Kia. So we do, if you don't know how we do things around here, we do about 6 classes, all new back to back, and then we repeat those 6 classes again. So it gives you 4 chances really to watch each class live and ask questions and all that good stuff. So we're going to start cycling back on our Hyundai and Kia class. So that'll be next week. Same time, same place. As always, 6 and 9 Eastern, 5 and 8 Central, 3 and 6 Pacific. If you want to watch on Zoom, go to snapon.com/OT, register there. Otherwise, the 6 p.m. class goes to our YouTube channel. If you are watching on YouTube, please make sure you like and subscribe. It really helps with that algorithm thing. So the more people that subscribe, the better. We just hit 30,000 subscribers. So thank you very much for those of you watching who are subscribers. It definitely helps out with our being able to offer this training. So please do so if you're not. Also, the 9 p.m. Eastern class goes live to my Facebook page. So it's facebook.com/SnapOnJason. You check it out there if you prefer to go on Facebook. If you're interested in any of our previous classes through here, anywhere from Intro to ADOS all the way through episode 100, which was last week, which is Hidden Gems of your Snap-on Scan Tool and everything in between. We did some component testing courses. We did our OEM specific training, right? So we have our CDJR. So I see somebody Ethan on YouTube just asked the question, when is Chrysler Ram? It was back 11 episodes ago, so probably 6 months ago maybe. So you can look that back up on YouTube. So if you go to youtube.com, if you just scan this QR code, should I say, that'll subscribe you to the channel automatically. And there is a playlist on the channel, if you're already subscribed, where you can watch live training. All available for free, 24 hours a day. They're all about 30, 40 minutes long. So feel free to go watch those, any and all of those. We did talk about a little component testing on EVAP back then, a couple years ago. That's probably 3-4 years ago. We just kind of brought it back because we haven't talked about it in a while. So that is YouTube. And then also, if we don't have your email address, you may be missing out. We send out periodic technical focus articles, SureTrack blogs, quick tips. Here's an example of an article right here on timing chains and how to check out stretch timing chain, things like that. So if you're not getting emails from us, please make sure you scan that QR code. It'll bring you to a form where you can enter in your email address, and we can get it that way. I also like to remind you that my buddy Keith also does free training every Wednesday and Thursday. Wednesday's on Zeus and Zeus Plus. Thursday is on Apollo and Triton tools. It is one time a night because it's about an hour and a half, hour and 45 minutes long. It starts at 7:30 Eastern. And it's pretty much everything from soup to nuts. Let's set up the tool. Let's talk about Snap-on Cloud. Let's talk about Security Link. Goes through everything from start to finish on the scan tool portion. That's about an hour for that. Then he takes a 5-minute break, and then after that, he goes through everything scope-related on the tools. Got a component test, lab scope, and all that. So very thorough class. Keith's been with us for well over 30 years. So definitely check him out as well. It's a good class. Also, if you were with us last week, which some of you were, some of you weren't, but if you entered the contest, we did a giveaway last week for anyone who was watching live or, within the first few hours. We had a QR code up there, and we gave away prizes. So the grand prize is this awesome lighted spinny sign. Kind of looks like an old gas station sign. It's pretty big, too. And we gave away a bunch of backpacks, too. Winners were contacted yesterday by email. And as of a couple hours ago, when I talked to our nice marketing person, she said she hadn't heard back from anybody. So if you entered the contest, check your email. Check your spam, too, I guess. But definitely check your email because you may have won. You need to get back to us before we can announce who the winners were. So just be aware, check your email if you did enter the contest last week. And with that, it is time for questions. So if you join late on Zoom and you're not sure how to ask, just look at the top of the bottom of your screen, wherever the Q&A button is, type in your question there. On YouTube, just feel free to use the live chat. I'll get to those in a second. Looks like I do have one on Zoom here. Let's see. So can the scanner do ECU relearn? It depends on what you're talking about when you mean relearn. So if I just need to kind of do like a handshake and write a VIN into it, most vehicles that need that, you can do that. You actually need to flash software on the computer like you do oftentimes for like Chryslers and a lot of other vehicles that ship you blank modules. Then you need a pass-through device. So J2534 pass-through device, Windows computer, all sorts of other devices to go along with it. So depends on what you mean by relearn. But if it, like I said, if it's a simple handshake and a VIN, then good to go on most vehicles. Otherwise, you need some other specialized tooling and accounts with the manufacturers and all that sort of stuff. So, Jay, oh, looks like he didn't win. I double checked his email, I guess. So unfortunate, but you know, there may be another one in the future. So hello, thanks for the class. Thank you, Jay. Thank you as always. I've seen you joined quite a few times here, so appreciate that. Appreciate the repeat return, folks. Nick checking in from UK on YouTube. It's very late at night. Go to bed, Nick. It's a really it's always good to have you come on in and say hi every single week. The Winton, hello. Same with you. Welcome every single week you watch on YouTube. Colonel Buckshot says, I got my very first EVAP leak detector back in 2008, and it paid for itself many times over. I bet it did. Like I said, I was so frustrated because I worked for Subaru in the Northeast. And those two things are a really bad combination because all the crud they put on the road and all the snow we get and all the rust that gets up and in there and the mud and everything. And the worst thing was the filler necks because there was a plastic cover that they put over the filler necks that didn't have a way to drain out the mud. So dirt would get in there and it would just sit there and it would collect water and it would go on the filler neck and it would eventually rot out the filler neck. So a lot of EVAP leaks there. So yeah, definitely would have paid for itself many times over, but you know, whatever. Let's see. Ethan says hello. And he asked when Chrysler Ram was. So I already answered that question, so that's good. Ethan also says, thank you. Appreciate the training. Very useful. You're welcome. Thank you for watching. Always very nice to have people watching. And then Ethan also says us Chrysler techs hate it too. So there you go. So a lot of horror stories when it comes to EVAP stuff or flashing. I think that might have came when I was answering that flashing question. And then Nick loves the free training as always. So always very good. So with that, I think that's it. I think we got all the questions. So I would like to say, if I can, there we go. Thank you very much for spending a little bit of time with me. Hopefully we learned some more little tidbits and tricks about EVAP systems. Hopefully you'll join me next week for our vehicle OEM specific Hyundai Kia class. Hope you enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.